From the previous exercises, we know that we can use the shard key to identify the DOM that a particular record lives on. However, this illustrated example only showed a few records in a DOM. In reality, each DOM can hold several million rows of data. So how do we further reduce the number of records that need to be scanned during query execution to identify a particular value? Kinetica does this using chunks. Chunks horizontally split the data in a DOM to reduce the number of unnecessary table scans. The chunking is done automatically by Kinetica when the data is loaded into memory. Each chunk has metadata associated with every column in it. This allows Kinetica to skip those that don't need to be scanned for a particular value. Let's explore this more concretely with an example. Assume that this is all of the data that is inside a particular DOM. Let's call it DOM1. This is the same orders table that we've seen before that has been sharded on the order ID column. By default, Kinetica automatically groups data into chunks that are 8 million rows each. This chunk size is configurable. If you notice the values in the table, you will see that there is no particular sort order that has been imposed on any of the columns in the chunk. This is because, by default, the data is simply organized based on the insert order of the shard key. When the records are inserted into a table, they're inserted into the first chunk until it is full, and then a new chunk is allocated. We will soon see how we can optimize the way that the data is organized using partitioning. But for now, let's work through a query to see how, even with the default settings, chunks can help improve query performance by reducing the number of records that need to be scanned. Say we want to find out the number of orders per city in New York State. We can do that using this query, which first filters all the records where the shipping state is New York, and then groups by the shipping city column to calculate the number of orders. Let's work through this using what we have learned so far about chunks. Each chunk has metadata for every column which stores the min and max values. So when the first part of the query filters for shipping states that are New York, Kinetica uses the metadata for shipping state to identify that chunk 1 and chunk 3 are the only chunks that contain a range of values that include New York State. So this allows Kinetica to skip chunk 2 and chunk 4 entirely when executing this query. As a result, we cut the number of records that need to be scanned by half. The thing to note here is that the values for shipping state were in no particular order. So we could have further reduced the number of records to be scanned if, say, the shipping state had been pre-sorted, which might have organized the data such that all of the values for New York State were in the same chunk, allowing us to achieve better chunk skipping. Partitioning, which we will cover next, is a more finely tuned and feature-rich way to do exactly this. Partitioning provides a way to organize the data to optimize chunk skipping. Kinetica currently supports 4 types of partitions: range, interval, list, and hash. The basic idea with all of them is that they allow for fine-grained control over how the data can be organized. For instance, the range partition could be used to organize, say, a date column such that all of last week's data is stored in a single partition, so that queries that filter for the most recent data can easily skip all the other chunks with older data. Let's go through an example to see how partitioning can improve chunk skipping. This table is partitioned on the shipping state column. Records for each state is a separate partition. Each partition is then divided into chunks. Notice how all the chunks don't automatically fill up to 8 million records before moving to the next. This is because chunks are now created and filled within each partition. Let's look at a query to understand how partitioning makes chunk skipping more effective. Let's say we would like to identify all the orders that were shipped to the city of Albany in New York. Since it is not guaranteed that cities in the US have unique names, it is not enough to only filter on the city column. So the query should also filter on the shipping state column. The first step in the query is to scan for the shipping state of New York. Since the data can be partitioned based on the shipping state, the metadata for all the chunks outside the New York partition will not include New York and will be immediately skipped. The next step is to filter for the city of Albany from the remaining 2 chunks within the New York partition. Chunk 1 in the New York partition only includes values that range from Brighton to Lewis, which means that the alphabet range for shipping city column in chunk 1 is B to L, which does not include Albany. So chunk 1 is also skipped in the scan, leaving just the data in chunk 0. So to summarize, partitions further reduce the amount of data that needs to be scanned by giving us tools to organize the data in a way that makes chunk skipping more effective.